You take a deep breath right now. Go ahead, breathe in. And with that one simple breath, you just invited a slow, invisible killer into your body. That's not a metaphor. That's not me being dramatic. That's actual chemistry. The very thing keeping you alive, oxygen, is also simultaneously tearing you apart from the inside and the wild part. It's been doing it your entire life, every single second. Right now, as you're watching this, how is that possible? How can something that's civis you also be what's destiro yang you? That's exactly what we're going to figure out today. And trust me, once you understand this, you'll never look at a rusty old nail or a sliced apple turning brown or your own aging face in the mirror the same way again. So let's start at the very beginning. What even is oxygen? I mean, we learned about it in school. Sure, it's in the air. We breathe it. It's good. But that's like saying a knife is good for cooking and just leaving it there. Technically true, wildly incomplete. Oxygen is what scientists call a highly reactive molecule, which basically means that RALY wants to interact with other things, like desperately. Imagine oxygen as this incredibly enthusiastic new coworker who just started their first job. They walk in the door and immediately they're like, hey, can I help? What are you doing? Let me be part of that. What about teach ice thing over here? Can I get involved? They just can't leave things alone. And chemically speaking, that's literally what oxygen does. It bumps into other molecules and it tries to steal their electrons. Now, electrons, okay, quick detour, I promise this will make sense. Everything, and I mean everything, is made of atoms. Atoms have this tiny positively charged center called a nucleus, and then swarming around the outside, these even tinier negatively charged particles called electrons. Now, normally, atoms like to hold on to their electrons, like, those are mine, thanks. But oxygen is kind of a bully. It comes along and goes, actually, I want some of those. And it TKS them, or sometimes it shares them in this really unequal, uncomfortable way where oxygen is kind of hoarding. This stealing or unequal sharing of electrons, that process is called oxidation, and it is happening absolutely everywhere all the time, constantly. When iron rusts, oxidation. Iron meets oxygen, oxygen swipes electrons, and the result is that reddish, crumbly stuff we call rust. The iron is literally being broken down slowly, molecule by molecule. When you cut open an apple and it turns brown, oxidation. The cells of the apple, now exposed to air, start reacting with oxygen. The apple isn't rotting immediately, it's oxidizing. It's literally doing a slow chemical unraveling right in front of your eyes. When butter goes rancid, oxidation. When old paintings fade, oxidation. When wine turns into vinegar, oxidation. It's happening EVRWHR. And now here's the part that kind of breaks your brain a little. The same process, the exact same chemical behavior is happening inside your body right now, inside your cells. Every moment of every day, your body uses oxygen to generate energy. That's the whole point of breathing. Get oxygen in, use it to burn fuel, get energy out. And this process is incredible. Like, it's one of the most elegant systems in all of biology. But here's the thing about elegant systems. Sometimes they have exhaust. When your cells use oxygen to produce energy, most of it gets used up cleanly. The oxygen does its job, combines with hydrogen, forms water, everything's tidy. But sometimes a rogue oxygen molecule escapes the process a little wrong. It ends up with an extra unpaired electron. And now it's not just eager, now it's desperate. An oxygen molecule with an unpaired electron is called a free radical. And a free radical is like our enthusiastic coworker, but now they're unhinged. They're so desperately trying to find a partner for that lonely electron that they'll seek anything nearby. They'll grab electrons from the walls of your cells, from proteins, from DNA. And when they steal electrons from wire molecules, they damage them, sometimes permanently. This is oxidative stress. Your body's slowly being rusted from the inside, not metaphorically, chemically, actually. And the scary part, or I guess the fascinating part, depending on how you look at it, is that this isn't some rare disease or something that only happens to unhealthy people. This is just life. The price of being alive, the price of using oxygen. Every breath you take creates a little bit of this cellular chaos. Every burst of energy your body produces generates some free radicals. Every moment of existence is slowly writing wear and tear into your biology. Okay, but wait. If this is true, if oxygen is constantly damaging us, why are we not just dissolving? Why aren't we falling apart instantly? Great question. Because your body is INC belly. Seriously. Evolution spent hundreds of millions of years solving exactly this problem. And the solution it came up with is a class of molecules called antioxidants. You've probably heard that word before. On juice bottles, supplement ads, health food labels. But what actually are they? Okay, so remember how free radicals are desperately searching for an unpaired electron. Antioxidants are basically the volunteers who go, hey, here, take mine. They donate an electron to the free radical. The free radical calms down. Crisis averted. Your cell doesn't get damaged. Your body makes antioxidants on its own. It's built a whole defense system. But you can also get them from food. Vitamin C, vitamin E, beta, carotene. Things found in fruits and vegetables, which suddenly makes the advice more vegetables feel a lot less like nagging and a lot more like actual chemistry. So this is the situation your body is in every single day of your life. Free radicals on one side, trying to steal electrons and cause damage. Antioxidants on the other side, neutralizing them before they can. A constant, invisible war, playing out in every cell, in every tissue, in every organ. And when the balance tips, when there are more free radicals than antioxidants can handle, that's when things start going wrong. That's when oxidative stress builds up. And oxidative stress has been linked to a lot, like a really sober amount of stuff: heart disease, cancer, Alzheimer's, diabetes, cataracts, arthritis, and maybe most universally relevant to all of us, aging. Like actual aging, the wrinkles, the gray hair, the slower healing, the forgetting where you put your keys. A significant portion of what we call getting old is just accumulated oxidative damage. Your cells have been taking hits for decades. Some repairs were made, sure, but some damage stuck, and over time that damage adds up. You are in a very real sense slowly rusting, just like the iron nail, just like the apple, just like the butter going rancid, on a much slower timeline with much more complex chemistry, and an absolutely incredible repair system doing damage control the whole time. But still, the same fundamental process. Oxygen, the essential molecule that is also quietly the thing behind so much of what makes us mortal. Kind of poetic, really. Now let's zoom in even closer, because I want to show you where this is actually happening. Inside your cells, there are these tiny little structures called mitochondria. You might remember them from school. They're called the powerhouse of the cell, which might be the most famous biology fact ever, and also kind of hilariously undersells what they actually do. Mitochondria are where most of your energy gets made. This is where your cells take in oxygen and fuel, basically from the food you eat, and turn it into a molecule called ATP, which is basically the universal energy currency of life. Everything your body does, every heartbeat, every thought, every blink, every breath is powered by ATP. And making ATP requires oxygen, which means the mitochondria are ground zero for free radical production. Because this whole process is incredibly efficient, but not perfectly efficient. Maybe 1 to 2% of the oxygen flowing through your mitochondria ends up as free radicals rather than getting cleanly converted. 1 to 2% sounds small, but your cells are doing this billions of times every second. So even 1% of billions of reactions is still an enormous number of free radicals being produced every second of every minute of every hour of your entire life. It never stops. And here's the really mind-bending thing. The mitochondria themselves take a lot of the damage. Remember how free radicals attack whatever is nearby. The nearest thing is usually the mitochondria. So the mitochondria gets hit. It gets damaged, and damaged mitochondria. They produce even more free radicals. It becomes a feedback loop. Damaged mitochondria, give more free radicals, give more damage, give more mitochondria problems, give even more free radicals. This feedback loop is actually one of the leading theories about why we age. As you get older, your mitochondria accumulate damage. Damaged mitochondria produce more free radicals. More free radicals cause more cellular damage. More cellular damage leads to more aging. It's not the only theory about aging. Biology is complicated, and we're still figuring a lot of this out. But the oxidative damage theory is one of the most well-supported ones we have, and it all traces back to that one eager, electron-stealing molecule, oxygen. Okay, now let's talk about something really counterintuitive, because here's the part that surprises most people. More oxygen isn't better. In fact, more oxygen can sometimes be worse. Think about it. If the problem is that oxygen creates free radicals when it's used to make energy, then more oxygen means more opportunity for free radicals to form. This is why you shouldn't just breathe pure oxygen all the time, even though it sounds like it would be great. Concentrated oxygen actually causes toxicity. Premature babies who were given too much supplemental oxygen in the past developed serious eye damage because of oxidative damage. High-altitude climbers who breathe from oxygen tanks can experience lung irritation. Too much of a good thing. Even water, pure, life-giving water, will kill you if you drink too much. And the same is true of oxygen. We've evolved to thrive on about 21% oxygen, which is what's in regular air. That's the sweet spot evolution found. High enough to power our bodies efficiently, low enough not to overwhelm our antioxidant defenses. a delicate balance, calibrated over millions of years, which actually makes you think about how astonishing it is that this all works at all. You've got this incredibly reactive gas, one of the most reactive in the universe, actually flowing through your blood vessels, carried around by hemoglobin, which grips oxygen and then lets it go exactly where it needs to go. And your body has developed this whole elaborate system to use that reactive gas for energy while simultaneously protecting itself from being destroyed by it. It's like hiring a pyromaniac to be your chef. Like, yes, they'll cook the food brilliantly. They're genuinely the best at their job. But you've also got to fireproof the entire kitchen and keep a constant eye on things. That's your body's relationship with oxygen. Brilliant, necessary, slightly terrifying, and managed with extraordinary precision. Now, let me tell you about something that makes all of this even more fascinating. Because oxidation, as destructive as we've been talking about it, is actually also used on purpose in your body. Your immune system deliberately uses free radicals as weapons. When your immune cells detect a pathogen, a bacteria or a virus that's invaded, they actually generate free radicals intentionally. And they use those free radicals to ATACK and destroy the invader. So the same thing that damages your cells when it's out of control is weaponized to protect you when it's controlled. It's like having a flamethrower. In the wrong hands, or used carelessly, catastrophic. In trained hands, deployed precisely, incredibly effective. Free radicals are your immune system's flamethrower, which is also one reason why inflammation, which involves a lot of free radical activity, can be both helpful and harmful depending on the context. Short-term inflammation after an injury, helpful. That's your immune system deploying the flamethrower to clean up damage and fight infection. Chronic, long-term, low-level inflammation. That's the flamethrower left on accidentally, and it causes the kind of ongoing oxidative damage linked to all those diseases we mentioned. Heart disease, Alzheimer's, cancer. A lot of these chronic diseases can be traced back to the same root chronic inflammation plus chronic oxidative stress, which makes sense when you realize they're basically the same chemical story. Okay, we've covered a lot of ground. Let me bring it all together in a way that actually matters for you, a human living your life. Here's what's really going on. Every second, your cells are running this miraculous energy producing process. Every second. That process generates free radicals as a side effect. Every second, your antioxidant defenses are working to neutralize those free radicals before they can cause damage. And every second, a little bit of damage gets through anyway. Over years and decades, that damage accumulates. And that accumulated damage is a huge part of why we age, why our cells lose function over time, why our risk for certain diseases goes up as we get older. Now, can we slow this down? This is where it gets interesting, because we actually have some influence over this. Not total control. We can't stop oxidative damage entirely. It's the price of using oxygen, and we're not giving that up. But we can tip the balance. Here's the things that are known to crank up oxidative stress beyond your body's ability to handle it. Smoking, air pollution, excessive alcohol, obesity, chronic psychological stress, ultra-processed foods. Too much intense exercise without recovery. Wait, exercise causes oxidative stress. Yes, actually. Exercise generates free radicals. That's one reason your muscles are sore after a tough workout. But here's the wild thing. Moderate, regular exercise actually makes your antioxidant defenses steer on GR. Your body responds to the mild oxidative stress from exercise by upregulating its own antioxidant production. It adapts. It says, okay, clearly we're doing this regularly. Let me upgrade the defenses. This is called hormesis, the idea that a small amount of stress actually makes you more resilient. Like how vaccines work. Small dose of something harmful. Body adapts. You're better protected. Exercise is basically hormesis for your mitochondria. Small oxidative stress, body upgrades response, net benefit, which is why, paradoxically, the advice to take antioxidant supplements before intense exercise might actually be counterproductive. If you flood your body with antioxidants, the free radicals from exercise get neutralized too quickly. Your body never experiences the mild stress. It never upregulates its own defenses. You get less adaptation, which is kind of the opposite of what people taking those supplements intend. Biology is weird. Okay, so what diets help? Eat real food. I know that sounds boring. Like, eat your vegetables is not the thrilling revelation you were hoping for after all this fascinating oxidation talk. But it's genuinely the most evidence-backed thing we know. Colorful vegetables and fruits are loaded with naturally occurring antioxidants, and they come in combinations and ratios that work together in ways we don't fully understand yet. When scientists try to extract individual antioxidants and put them in pills, the results are often disappointing. Sometimes they don't work as well. Sometimes they make things worse. The matrix of compounds in real food seems to matter. Evolution figured out which packages of molecules protect against oxidation over millions of years. A blueberry is not just one antioxidant, it's hundreds of them interacting. A supplement is not a blueberry. Not sleeping enough dramatically increases oxidative stress. Chronic stress does too. Cortisol, your stress hormone, promotes free radical formation. Being sedentary is bad. Moderate exercise, as we said, is actually protective. And then there's the simple passage of time. Because even if you do everything right, sleep well, eat well, exercise moderately, avoid smoking and excessive drinking and chronic stress, you still age, just possibly more slowly, and possibly with less disease along the way. The oxidative damage still accumulates. The mitochondria still gradually lose function. The free radical production still happens every second. But the rate at which it tips from manageable to damaging, you have some influence over that. And honestly, knowing this changes how I look at things. When I see an apple browning after I cut it, I think, that's the same chemistry happening in my cells. When I see rust on an old iron fence, I think, that's a slowed down version of what age does to tissue. When I take a deep breath of fresh air, I think, right now, oxygen is flowing into my blood, powering every cell in my body, and simultaneously, with every single molecule, slightly pushing me toward the entropy that everything in the universe eventually faces. There's something beautiful and terrifying about that at the same time. That the very thing you need to live is the thing that makes you mortal, that every breath extends your life, and also, in a tiny way, contributes to its end. That the most fundamental transaction of life, oxygen in, energy out, has this bittersweet fine print. You can't unsubscribe from oxidation. It's the tax that life pays for using the most powerful energy system the biosphere ever developed. But your body, the result of hundreds of millions of years of evolution, built the most extraordinary damage control system the universe has ever seen. And most of the time, it works beautifully. Imperfectly, but beautifully. And that, to me, makes every breath feel a little different, a little more meaningful. A tiny act of biochemical heroism. Your body negotiating with one of the universe's most reactive molecules. Making energy, making life. And keeping you going for just one more moment. Pretty incredible when you think about it. Okay, one last thing, because I want to leave you with a thought that might actually stick with you. Next time you leave an apple out and it starts browning, don't throw it away immediately. Just look at it for a second. Watch the oxidation, because that slow, visible chemical process happening on that fruit. That's the same force that's been quietly operating in the background of every living thing on Earth since oxygen first appeared in the atmosphere billions of years ago. You're watching evolution's oldest adversary. And in your own body, right now, you're winning the fight, for today at least, which honestly is pretty good. Thanks for watching.